Hello everybody. Let's do this review for the quest. It's not quite a quiz, not quite a test, for Unit 4 on trig identities. 8 questions total on the quest. 2 that you're going to have to simplify. So there are 2 problems like these 2. Now simplify, of course, means try to get it to one word. If you can't get it to one word, maybe it's one number. It might be like tangent times cosecant, something like that, but it's relatively small in terms of the quantity of words it is. So for cosecant, tangent, cosine, nothing squared. You can't use Pythagorean identities. Let's switch everything to sine and cosine and see if we can get some common denominators. Tangent, of course, is sine over cosine, and then cosine is just cosine of x over 1. Cosines cancel, and now we need to get a common denominator to put these 2 fractions together. The only denominator is sine. So we'll multiply that second fraction by sine of x over sine of x. This will result in 1 minus sine squared over sine when we put those 2 fractions together. 1 minus sine squared is cosine squared, and there's not much you can do with this. You could make it cotangent, cosecant, but it's probably not worth it. We'll just leave it like that. So I guess if you wanted to, because remember this would be cosine over sine, and then a cosine over 1 if we split it up. So this would be cotangent x cosine x. So if you didn't want to leave it with any fractions, you could do it that way. It's a little bit vague, sorry. It's hard to know exactly when you're finished on these. Like I said, there are 2 of them on the quest. Still calling it a quest. So for number 2, let's switch everything to sine and cosine. I'm going to start up here. So we have sine theta over 1 minus 1 over sine theta. Well, I feel like we just simplified that fraction. The denominator, of course, cosine over sine. So let's start with the top. Since we just did it, it was a different order, but we know that the common denominator is going to be sine. So in this case, the sine gets multiplied on the first fraction, and it's going to be the other way from the last answer. It's going to be sine squared minus 1. This is over sine. And then, of course, this whole thing is on top of cosine over sine. Now, if you're good with your complex fractions, then you know the denominators cancel. If you want to keep just writing it out, these 2 make it sine theta times sine squared minus 1, sine squared theta minus 1. And then these 2 make it sine theta times cosine theta. Either way, the signs will cancel out. Of course, sine squared minus 1 is cosine squared. And then we have a cosine on the bottom still, which reduces to just a plain cosine. This is a little bit more reasonable about how they reduce. The first one was a little bit strange. All right. Get rid of my little line there. So on this next part, you'll have one problem like this. This is actually how the quiz starts. So be prepared to draw some triangles, be prepared to label your triangles, and use your sum and difference identities. I'm going to draw the triangles over here. We have one in quadrant 2 and one in quadrant 1. So alpha is in quadrant 2, beta is in quadrant 1. Alpha gives you the sine, so the sine is opposite over hypotenuse. And beta gives you cosine, which is adjacent over hypotenuse. Well, this is a 5, 12, 13, so we know that that's 12. Whereas the sine triangle, the alpha triangle, rather, we don't know what that is. So you have to use Pythagorean theorem. So we'll have 9 squared plus x squared equals 100. X squared equals 91, and the square root of 91 is going to go right here. Now you can expect that same thing on the quest, where you have kind of a nasty radical to deal with. It won't simplify. It kind of makes it a little bit easier, actually, because it's not going to be like a number that you can simplify. So it will be nice and easy to deal with, like this radical 91. So then we'll just put it together. The identity says the sine of alpha minus beta, sine alpha cosine beta, minus cosine alpha sine beta. So that's where the numbers go. And when you do this, get rid of the sine and cosine. A lot of you keep holding on to the sine and cosine. You can't do anything with the words. So the sine of alpha, when we evaluate that, you get rid of the sine and the name of the angle, and you replace it with the actual opposite over hypotenuse. So in this quadrant, sine is positive, plus they gave that to us, so this is 3/10. Cosine beta, they also gave us that first quadrant, positive. Whoop, that's 5/13. Cosine alpha, now we're back to the second quadrant. Cosine is negative in that quadrant, so it's going to be negative radical 91 over 10. Sine of beta, sine is positive in this quadrant, so we have 12 over 13. Now, no matter if the radicals are in the top or the bottom, you generally will get a common denominator here. So let's take a look. We have 15 over 130 minus 12 radical, oops, actually it's plus, because it's two negatives there, 12 radical 91 over 130. Common denominator, but you can't really do anything with this 15 and this 12 because one's stuck to the radical and one isn't. So we're just going to have 15 plus 12 radical 91 over 130. 4 does not go into 15. 3 does not go into 130. 2 does not go into 15. Nothing reduces. The radical's on top. And that's what you can expect from the quiz as well. Kind of an ugly radical, but really not much arithmetic. Now for number 4, you'll have one problem like this. It tells you exactly what to do, sum or difference identity. So since it's got a 5 at the end, pick the 45. So this will be, I would at least, cosine of 45, and then 195 minus 45 is 150. You have to choose two angles that are on the unit circle. So this is the other sum or difference identity. This is the cosine one. So we're going to have cosine 45, cosine 150. And then this will be a minus in the middle. Sine of 45, sine of 150. So now again, we get rid of the words and we put in the numbers. So this is positive, radical 2 over 2. Now the cosine of 150, that's second quadrant, that's going to be negative, and it's associated with the 30 or the pi over 6, so that's going to be radical 3 over 2. Minus sine of 45, radical 2 over 2. Sine of 150, that's second quadrant, sine's positive there, it goes with the 30, so it's like sine of pi over 6, which is 1/2. Now when you multiply this, you get negative radical 6 over 4 minus radical 2 over 4. Multiply straight across the top, straight across the bottom. Can't really do much with that, except kind of write it as one fraction. And you're finished. Now you can use your calculator on the whole thing, but you cannot have a decimal answer on any of this stuff. Now, right through here, number 5 and 6, there's only one like this. You'll have to draw another triangle most likely, and be prepared to, use Pythagorean theorem if necessary to simplify that. So I'm going to put my triangle over here, I guess. I had some space. So we know that the cosecant is 3, and we're in quadrant 1. So quadrant 1, cosecant goes with sine. So if the cosecant is 3 over 1, that means the sine is 1 over 3. So opposite over hypotenuse, not a triple. Use Pythagorean theorem. 1 squared plus x squared equals 3 squared. So 1 plus x squared equals 9. So we're looking at x squared equaling 8. So the square root of 8, this is up to you. You can simplify it right now, or you can leave it radical 8. If you simplify it right now, it's radical 2 over 2. I'm going to leave it radical 8. Because I know I'm going to have to simplify it later anyway. So I'm just going to leave it like that. So for my cosine of 2 theta, I'm going to go ahead and use cosine squared theta minus sine squared theta. So the cosine, everything's positive, so I don't have to worry about my signs, but the cosine is radical 8 over 3. We're going to square that, minus 1/3 squared. So this is 8/9 minus 1/9 which is 7/9. Done. Tangent of 2 theta. This one's a little bit weird. I would simplify the radical on top, but not the bottom. Because on the top, you're multiplying by 2. So I'm going to call this 2 over 1 times 1 over 2 radical 2. Now the denominator, I'm going to call this 1 minus 1 radical 8 squared. Because I'm going to square it anyway. I'd rather square the 8 than the 2 radical 2. So the top, the 2's cancel. We get 1 over radical 2. The bottom, this is 1 minus 1/8. Now you can put that in the calculator. I can't have a decimal. I'm going to just do it myself. This is 8/8 minus 1/8. So this is 7/8 on the bottom. At this point, your calculator is a little bit useless because you cannot have a decimal, and your calculator likes a decimal with the radicals. So we get 8 over 7 radical 2. Can't have a radical in the bottom, so we're going to rationalize this. So we get 8 radical 2. Now the bottom, radical 2 times radical 2, that's 2, times 7, that's 14. So this reduces to 4 radical 2 over 7. Now for the sine of 157.5. It's got a 0.5. Obviously you can see that. So you're going to have to take this angle and double it. Because we can't do anything with the 0.5. You can't add anything to get to the 0.5. So this is your half angle identity, meaning find an angle, take half of it to get the 157.5. Now the sine of 157.5 is positive because it's right here. So our answer will be positive. But we're going to have to use the sine of 315. That's what 157 times 2 is. That's what's going to go inside the formula. And the formula is 1 minus the cosine of your number that you just generated over radical 2. Remember, keep your radical signs, keep them separated, and keep separating them as you go. So the cosine of 315, this is in the 4th quadrant, cosine's positive there. So now we have 1 minus radical 2 over 2 on top of plain radical 2. I'm going to turn my 1 into 2 over 2. And so now as I go, I'm going to keep making my radical sign separated from top to bottom. So the top is radical 2 minus radical 2. The bottom has a plain radical 2. The denominator of the fraction is radical 2 over 1. And then we fix this. So you can tell the radical 2's cancel, or not, it's up to you. So we get radical 2 minus radical 2. And then the bottom, oh, I guess they don't cancel, my fault. They multiply, sorry. We get rid of the radical sign. Radical 2 times radical 2 is a plain 2, and this is finished. This is a double radical sign. The answer is positive. On the back, I know you've got 3 here. There are only 2 solving equations. They're going to have the similar domain to this, where it's degrees. It might be 0 to 180, but it might be 0 to 360, but it won't be anything weird. It won't be negative infinity to infinity. So for number 8, we're going to take that secant squared, because the word tangent we can't really change. And we're going to look at the Pythagorean identities, and this is going to be, the 2 stays there. We're going to have tangent squared plus 1 minus tangent to the 4th, which I know seems weird. I'm going to move the 1 over and set this thing equal to 0. Tangent to the 4th I really want first, so that's negative tangent to the 4th, which I'm going to have to fix. Distribute this, so then we have plus 2 tangent squared plus 2 plus that 1, that's from right there. Now we're going to have to go through and change all the signs. So tangent to the 4th minus 2 tangent squared minus 3. And now we factor. Tangent squared and tangent squared. The only way to get 3 is 3 and 1. And the 3 has to be negative and the 1 positive. So now we get that the tangent squared is 1. So tangent is positive and negative 1. Here we get that the tangent squared is 3. So tangent is positive and negative radical 3. Now if you have to think through this in radians, do so. I don't know why I have some stuff crossed off here. So the tangent of x equals 1. All the 45s. Positive and negative 1, all of them. So we have 45 Then we have 135. It's hard for me to think. And you have your calculator. You could do these in your calculator. 225 and 315. Tangent equals radical 3 at pi over 3s, which is the multiples of 60. So 60, 180 minus 60 is 120. 180 plus 60 is 240. And 360 minus 60 is 300. For number 9, got a lot going on here with number 9. So we're going to have to switch things to sine and cosine, and then we're going to have to use Pythagorean identity, it looks like. So this will be cosine over 1. Tangent is sine over cosine. Cosine squared, because see the cosines cross off, so I'm going to get rid of this here. I'm going to write this as -2. I'm going to take that cosine squared out, and I'm going to put in 1 minus sine squared. You can move the 1 over if you want. I'm just going to leave it over here for the time being. It's got a lot going on here. So now if we simplify this a little bit, we get the sine of x minus 2 plus 2 sine squared x plus 1. Rearranging this a little bit, 2 sine squared x plus sine x. And then we have the -2 and the 1, so minus 1. Factor this out. The only way to get 1 is 1 times 1. And so we want this one to be a positive, so we get 2 minus 1. So now we get that the sine of x is equal to 1/2, and the sine of x is equal to -1. We're in degrees. Sine is 1/2, right, in first and second quadrant, so 30 degrees, 150 degrees. Sine is -1 straight down, 270 degrees. For number 10, cosine of 2x. We got to look at the formula sheet. And we should probably, I don't know. Maybe if we make the sine squared 1 minus cosine squared. There's a lot of choices here. So if I put this into cosine, because I see these are both in cosine, so I'm going to switch this one to 1 minus cosine squared plus the cosine. Actually, let's switch this too. Let's switch this to the formula with cosine in it. We might as well switch them all. This will be 2 cosine squared. This is x, not theta. And that's -1. And then this minus cosine is from the original problem, still equals 0. It's messy, so we substituted in this quantity and this quantity, putting everything in cosine. 2 cosine squared minus cosine squared is cosine squared. Then we have minus cosine x, and then we have 1 minus 1. That's 0. So they have a cosine in common, and we're left with cosine of x minus 1. So cosine of x equals 0. Cosine of x equals 1. We're still in degrees, so cosine is 0 at 90 and 270. And cosine is 1 at 0. All right, now this last kind is when we have a number in front of the angle. So the first thing you do is you multiply your domain by this number right here, 5. So 0 times 5 is 0. 360 times 5, 1,800 degrees, which means we're going around 5 times. Holy cow. So now we're looking for the sine of what equals 1. There's only one answer, and that's 90 degrees. Then you got to add 360, 450, plus 360, 810, plus 360, 1170. We still have some room to go here. Plus 360, 1530. And if you add 360 again, it's bigger than 1,800. Then you go back and you divide all of these numbers by 5. And so that's how you get these weird angles. 18 degrees, 90, 162, 234, and 306. And that's the whole quest.